Now complex numbers. This is the class. Listen. Now yesterday maybe I hope that one BD is given. BD is not completed. Let me first finish that particular bit. Z satisfy modulus of z minus 3 is equals to 4. Then find maximum and a minimum value of modulus of, this is the bit. Then find the maximum and a minimum value of that particular value. So here z satisfies the condition modulus of z minus 3 is equals to 4. It is already given. We have to find the maximum and minimum value of, this is the value modulus of z minus 5 minus 7i. Listen all of you. So here by the data according to the given data, if you observe, modulus of z minus 3 is equals to 4. First, what this value indicates? Modulus of z minus 3 is equals to 4 means. So if you observe here, it is modulus of, whenever if they given like this, immediately you can take z is equal to x plus iy. So here it is the value x plus iy minus 3 is equals to 4. If you simplify, x minus 3 whole square plus y square equals to 4 square. Since modulus of z means root of x square plus y square, root of real part whole square plus imaginary part whole square. If you simplify this value, modulus of x plus iy minus 3, of course root of x minus 3 whole square plus y square equal to 4. Directly if you squaring on both sides, then we will get the value x minus 3 whole square plus y square equals to 4 square is the value. So here if you observe, this equation indicates the circle equation. For the circle, what is the center of the circle will be 3, 0 and the radius is equals to 4. This is the value it will indicates. Now in the real numbers, in the complex plane or in the organo plane, if you draw the circle equation, then let this is the circle. Here the center 3, 0 na. So if you observe, let this is the center 3, 0 means that to radius is equal to 4 units. So this is the 4 units. So that means if you consider, let this is the real axis. Imagine you can draw, this is the axis 3, 4, 5, let it be 6 and 7. Maybe this is the point is 7, 0 and this side here it is 2, radius 4 units. So I'm reducing here 3, 2, 1, 0. This is the value minus 1, 0. So the circle position is like this. And here of course if you observe 3, 0, 2, 0, 1, 0, 0, 0. So here it is somewhere the imaginary axis will be like this. Okay, na? Like this. This is the origin. This is the imaginary axis and this is the real axis and the circle is like this. Now if you observe, what is this meaning? Indirectly yesterday I given the meaning of, geometrical meaning of modulus of z1 minus z2. What is the geometrical meaning of modulus of z1 minus z2? Modulus of z1 minus z2 means that is nothing but distance between the 2 points z1, z2. z1 represents one point in the orgone plane, z2 represents one more point in the orgone plane. Then modulus of z1 minus z2 means distance between the 2 points z1, z2. So here also z is any point here. Z is satisfying this point. That means z is nothing but any point on the circumference of the circle with the center 3, 0 and the radius is equals to 4 units. This is the value. Of course here the radius value is equal to 4 units. Now if you observe, modulus of z minus 5 plus 7i. For this maximum value, minimum value we have to find. That means here what is the point will be 5, 7. Then where this point lies 5, 7? Is the circle outside it lie or circle inside? You can cross check. Substitute the point there. In circle chapter we did. So if you substitute the point 5 comma 7, what it will be here? 5 minus 3, 4 plus y square value, y square means 49 minus 4, automatically greater than 0. So the point lies on the outside of the circle. So outside of the circle, that too 7 means I have that somewhere here the point is 5 comma 7, 3, 4, 5. 7 is nothing but y component, here it is the value. So somewhere let this is the point is 5 comma 7. Okay, so 5 comma 7 is the exterior point. Here if you observe, you will get somewhere the point is, here it is the point, some 5 comma 7. Now from this, z is any point on the circumference, then we have to find maximum and minimum value of this is the point. What about this meaning? Here it is the maximum and minimum distance of z from the point 5 comma 7, where what is the z value? Z is any point on the circumference of the circle. That means maybe if you observe here, this is the minimum distance, and if you observe, this is the maximum distance. This is one z value which will give minimum distance, and this is the maximum distance. How you can find this value? This is the point as, for example, if this is the point C, then minimum distance equals to, what is the minimum distance formula? Cp minus r. Again the circle concept. If it is the center, if you can take it, Cp minus r. What is the maximum distance, maximum distance is equals to Cp plus r. So here if you observe, here it is the complex number bit only, but if you know about all these things, what is this meaning geometrically, what is this meaning, and geometrically what we have to calculate here, if you understand all these things, then the bit will be easy. Okay, I hope that it is clear. Okay, next one more example, here I will give you. Here they given identify the region modulus of z minus 2 less than or equal to 8 and modulus of z minus 1 less than or equals to modulus of z minus 5. This is the bit. Okay, identify the region, okay, which is bounded by these values, modulus of z minus 2 less than or equal to 8 and modulus of z minus 1 less than or equal to z minus 5. So whenever if they given, immediately we have to take, in this case, let z is equals to x plus iy is the value. Immediately you can take z is equal to x plus iy. Now first if you replace z equal to x plus iy in this equation, now first you can find the value, modulus of z minus 2 less than or equal to 8. What is this geometrical meaning? Of course, modulus means, this is nothing but distance between z to 2. Then this value will be, if you simplify, x minus 2 whole square plus y square less than or equal to 8 square. So which equation indicates the circular disk? So this is the equation. If you observe here, 2 comma 0 is the center and radius is equal to 8 units, and that too this indicates the circular disk. Now here if you observe, if you simplify this value, this is the equation, modulus of z minus 1. Modulus of z minus 1 means, x minus 1 whole square plus y square less than or equal to x minus 5 whole square, plus y square is the value. Directly I am writing. Of course, now present you got one idea, no? Basing on that idea, maybe I hope that you can understand. Simplify this value, y square cancel, x square, here it is the value 1 minus 2x less than or equal to, here x square, this side x square cancel, here it is 25 minus 10x is the value. If you bring this value this side, 8x is less than or equal to 24, means x value less than or equal to 3 is the value. Now if you plot the graph by taking this is the real axis, and this is the imaginary axis, 0 let it be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let this is the point 10 comma 0. And here it is the value 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like this. 1, 2, 3, 4, 5, 6, 7, 8. You can mark it. What is center for this one? 2 comma 0. So 2 comma 0 means this one. And that radius is 8 units. Radius is 8 units means still here. And this side, of course, minus 6 is the value. 1, 2, 3, 4, 5, 6, minus 6 is the value. Radius is 8 units now. 1, 2, 3, 4, 5, 6, 7, 8. So, if you plot the circle will be like this. You will get. This is the circle. And according to this one, indicates the circular disk. Then here the two what is the value will be x value less than or equal to 3. X value less than or equal to 3 means 0, 0, 1, 2, 3. So x value less than or equal to 3 means till here you will get it. So automatically this is the reason you will get it. Okay, circular disk, the two satisfying this condition, automatically here you will get x value less than or equal to 3. That's it. The shaded region is the required region. Of course, sometimes they will ask find the area of the region bounded by the complex numbers which will satisfy the equation modulus of z minus 2 less than or equal to 8, modulus of z minus 1 less than or equal to z minus 5. Like this also sometimes they will ask. Okay. Next now one more point here. How you can write logarithm of a complex number? Here the logarithm of a complex number. For example, z is equals to r into e power I theta. Let you can take. This is the next one concept, competitive point of view. If you take z equal to r into e power I theta. Now, where r is equals to, what is r value? R means modulus of z and theta is nothing but argument of z. Already this is the polar form of mod amplitude form of a complex number. So z is equal to r into e power I theta is the complex number. Now we have to find logarithm of the complex number. So apply logarithm on both sides. Logarithm of z is equals to logarithm of, here r means mod z, mod z into e power I theta is the value. So this value, according to logarithm's property, how I can write this value? Logarithm of mod z plus logarithm of e power I theta is the value. Logarithm of mod z plus logarithm of e power I theta. Now which is equals to logarithm of mod z plus, how I can write this value? I theta into logarithm of e. Since here the formula logarithm of a power n is equals to n times of logarithm of a. Basing on the properties of the logarithm, I can write this value as I theta into logarithm of e. What is the value logarithm of e value? 1 only. So total here I got the value. That implies logarithm of z is equal to logarithm of z is equals to logarithm of mod z plus I into theta, means here you can get logarithm of z is equals to logarithm of mod z plus I into argument of z. This is the formula for logarithm of a complex number. Okay, so logarithm of z is equals to I into of z. Okay, remember this notation, logarithm of a complex number. So logarithm of a complex number z is equals to log of mod z plus I into argument of z. And one more thing, complex numbers, listen the video lectures and prepare notebook. That too, what I am explaining in the complex numbers, if you listen carefully up to IIT level, that is sufficient. So thoroughly you can prepare the classroom notebook. And meanwhile, I explain the doubts also in probability. Even you can send if you have any doubts also. Okay, ma'am. I hope that it is clear. Next, for example, z1 one complex number, z2 is one more complex number. Okay. Like a point you can listen. z1 z2 are the two complex numbers. Let z1 is equal to x1 plus i1, z2 equal to x2 plus i2. Let it be values. Now, what is z1 into z2 conjugate value? Calculate. z1 into z2 conjugate. So z1 means x1 plus iy1 into z2 conjugate means x2 minus iy2. Multiply these values. If I multiply these values, I can get x1 x2 minus iota x1 y2 plus iota y1 x2 plus y1 y2. Here, which is equal to x1 x2 plus y1 y2. This is the real part, plus iota into y1 x2 minus x1 y2 is the value. If I multiply z1 into z2 conjugate, x1 plus i1 into x2 minus i2, of course x1 x2, x1 of course minus iota x1 y2 plus I y1 x2. Generally minus will come, but iota square is there, iota square minus becomes a plus y1 y2. So this is the value. So this is known as the real part of z1 into z2 conjugate, and this is the imaginary part of z1 into z2 conjugate. And one more thing, what is the value z into z conjugate value? Mod z square. This is already we given. Okay, ma'am. If you observe here, into z conjugate, what is the value z into z conjugate value? Z into z conjugate equals to mod z square. Already that is given. Now here my aim is now modulus of z1 plus z2 whole square. I will calculate this value, modulus of z1 plus z2, which is equals to, how I can add this value basing on this one? Tell me. This is mod z square form is there. What is mod z square value, z into z conjugate. So this value I can write as z1 plus z2 into z1 plus z2 whole conjugate, which is equals to z1 plus z2 into whole conjugate means according to conjugate properties I can write this is the value. Z1 plus Z2 whole conjugate equals to Z1 conjugate plus Z2 conjugate. Now simplify this value. Z1 into Z1 conjugate plus next Z1 into Z2 conjugate, Z1 into Z2 conjugate plus Z2 into Z1 conjugate plus this value Z2 into Z2 conjugate is the value. Now which is equals to Z1 into Z1 conjugate. What is the value will be, mom? Modulus of Z1 square plus this value, mom. Z2 into Z2 conjugate. What about this value? Modulus of Z2 square. What is the remaining value will be, mom? Z1 Z2 conjugate plus Z2 Z1 conjugate. This is the remaining value. How I can write this whole value? Listen. Let this is the value Z1 plus Z2 modulus of Z1 plus Z2 whole square equal. This is the value taken as equation number 1. Now we have to find this value, ma. What about this value? Listen, ma. Now here I am calculating the value Z1 into Z2 conjugate plus Z2 into Z1 conjugate. This is the value we have to find it now. Listen, ma'am. Z1 into Z2 conjugate plus Z2 into Z1 conjugate. This value, ma'am, I can write as Z1 into Z2 conjugate plus this whole value. How I can write this value? This is the value I can write as Z1 into Z2 conjugate. Can I make this like this? Cross check one time. Z1 conjugate. Z conjugate. If Z conjugate this value only you will get it. Understand, ma'am? Once again, listen. Here they given Z2 into Z1 conjugate. In terms of getting this value, this first value as it is. Second value Z2 into Z1 conjugate. This value I can write as, ma'am, Z1 conjugate into Z2 conjugate again whole conjugate. One time for complex number conjugate, again if you write conjugate, again same value you will get it, ma'am. So again only you will get it. So this value I can write like this. Now here if you observe, ma'am, let one conjugate you can take as one complex number. If Z is any complex number, Z plus Z conjugate. What is the value? Z plus Z conjugate value. What about this value, mom? 2 times of part of Z. This is already we given. Z plus Z conjugate equal to 2 times of real part of Z. So here also if you observe, mom, this is Z plus this is Z conjugate. So what is Z conjugate value, mom? Z plus Z conjugate equals to 2 times of, I can write 2 times of real part of Z1 into Z2 conjugate. Now replace this value in this first equation. If I replace in this first equation, ma, therefore I can write conclusion. Therefore here it is the value, mom. You can get the value as Z1 plus Z2 whole square equal to what we are getting? Sorry, modulus, ma, here it is. Modulus of this complex number, here it is. So modulus of Z1 plus Z2 square equal to what we are getting, ma'am? Modulus of Z1 square plus modulus of Z2 square plus 2 times of real part of Z1 into Z2 conjugate. This is as one important point. Okay, ma? Remember this one. Got it, na? So modulus of Z1 plus Z2 whole square equal to, this is the formula. Modulus of Z1 square plus modulus of Z2 square plus 2 times of real part of Z1 into Z2 conjugate is the value. For example, if they given, mom, modulus of Z1 plus Z2 whole square equal to, mom, modulus of Z1 square plus modulus of Z2 square minus 2 into real part of Z1 into Z2 conjugate. This is the next formula. Basing on this one, just only there you will get a minus only. Minus only you will get now. So if you simplify, you will get this is the value. That's it. Next here it is. And once again next number, if you add them, and here one more point, z is equal to x plus iy. Z conjugate equals to x minus iy. In z and in z conjugate, what is the real part will be same only na? Either in z or z conjugate. What is the real part ma? Real part is same only. So due to that reason, in some books they will give here 2 times of real part of z1 conjugate into z2. That means whole conjugate of this one. What is the whole conjugate of z1 into z2 conjugate ma? If you did the conjugate value, here you will get z1 conjugate, z2 conjugate, whole conjugate, again z2 only. So this value, either they mention z1 conjugate into z2 or z1 into z2 conjugate, both are same formula. Don't confuse. Sir, you told me this one, sir. In some books they given some other manner, sir. Here conjugate is given, here without conjugate given. Both are same only, since we are taking the real part. So automatically, what is the meaning of real part ma? Real part means either the complex number or its conjugate complex number. Real part will be same. Okay. Next ma, if I add them these two values, next extension point, if I add them these two values, if I add them, what I can get? Tell me here it is. If I add them, I can get, that implies modulus of z1 plus, sorry, this is z1 minus z2 ma, z1 plus z2 whole square plus modulus of z1 minus z2 whole square equal to, sorry ma, here it is minus, don't confuse, okay, here it is minus, whole square equal to, add them 2 times of modulus of z1 square plus modulus of z2 square. This is the one more important formula. Just remember this formula. These are the basing on the modulus. You can take like this. Okay ma. Next. I hope that it is clear for you. One point is there. Here the point is modulus of z power n. Modulus or z power n modulus. For example, my if you take z is equals to r into e power I theta. What is z power n value will be? R power n into e power I theta whole power n only na. So r power n into e power iota n theta. That means modulus of z power n is equal to what is the value? R power n. Here z power n means you will get one complex number only na. So for that complex number, what is the modulus value? This is the modulus value. This is the modulus value. Okay. And that too here, this is the value I can written as r means again mod z only na. So mod z whole power n. So here the one more point is modulus of z power n is equals to mod z whole power n. This is also one more point you can remember. Modulus of z power n is equals to modulus z whole power n is the value. Got it now? Next. And few more examples. Let me clarify. Here one example is given. Find modulus of the complex number 2 plus 2 root 3 I 3 plus 4i 5 minus I whole by 4 plus 3i into 1 plus 2i. What is the modulus of the complex number? This is the value given. What is the modulus of this whole complex number? Simple logic, ma'am. What is modulus of Z1 into Z2 formula? Mod Z1 into mod Z2, na? That's it. What is the formula for modulus of Z1 by Z2 value, ma'am? Mod Z1 by mod Z2. With the help of these two formulae, you can simplify. So let this is the value you can suppose as Z only. For that one they are asking modulus. Therefore, mod Z is equal to mod of the first number into mod of the second number into mod of the third number by mod of the denominator value into mod of this value. So how you can modulus of for this one? Modulus means nothing but a root of real part whole square plus imaginary part whole square. For this one also root of 3 square plus 4 square, root of 5 square plus 1 square, root of 4 square plus 3 square, root of 1 square plus 2 square. Simplify, you will get the modulus of the complex number. Basing on the modulus, sometimes you will frame the bit like this. So few students, what they will do? Immediately they will simplify the whole number. They will simplify first. They will simplify the whole number. How they will simplify? They will multiply the denominator. They will multiply the numerators. After that, you will get one complex number. Then what the complex number you got in denominator? With that conjugate they will multiply. That is very lengthy method. Don't do like that. Simply this is the bit basing on the modulus of the complex number properties. So what is the modulus of the complex number properties? This one only. Simply you can apply. This is the logic. Modulus of Z1 into Z2 equals to mod Z1 into mod Z2. Modulus of Z1 by Z2 equals to modulus of Z1 by modulus of Z2. Apply the concept, you will get the answer. Next, for example, Z is equals to R into e power I theta. Let Z is equals to R into e power I theta. Then Z power n is equals to, what is Z power n value? Here you will get R power n into e power iota n theta. So here what is the argument of Z power n value? Tell me. What is the argument of Z power n? This is one complex number only, na? For this Z power n, it is complex number. This is the modulus value. This is the argument value. So what is argument of Z power n value? Here it is. This is the argument n theta. So which is equal to n times of argument of Z. N times argument of Z. Of course you can add 2n pi. Why I am adding 2n pi or 2k pi? Why I am adding 2k pi? Since this is it should be, when you are applying n into argument of Z, it should be in the principal region. What is the principal region I given? Principal region means belongs to from minus pi to pi is the value. This is the principal argument value. So always the principal argument value lie from open interval minus pi to close interval pi. Even if you find the argument value, if you will get n into argument of Z is not in the principal argument value, just observe the position where it will be. Basing on that, you can add or subtract it. Keep the total value in the principal region. That's it. So here the formula is, if Z is any complex number, Z is a complex number with argument of Z is equals to theta, then argument of Z power n is equal to what is value? N into argument of Z plus 2k pi is the value. Why I am writing this value means in order to keep the argument in the principal region. So here the basic formula is this one. Argument of Z power n is equals to n into argument of Z. argument of z power n is equal to n into argument of z plus 2 pi. Okay, basing on that value you have to keep the total value in the principal argument region. This is also one more important formula competitive exam point of view. Okay, next ma'am. I hope it is clear for you this concept also. Prepare the notebook, that is very very important. Anyway, video lectures are there, don't feel if you prepare the classroom notebook now, it is very very useful to you. So compulsory prepare the classroom notebook. Next, now one example is given here, the basing on the modulus concept one example is given, trigonometric geometrical application bit. Here the example is z1 comma z2 comma z3 are vertices of a triangle ABC with they given modulus of z1 equal to modulus of z2 equals to modulus of z3. Then find complex number associated with orthocenter. This is the bit. Okay, this is the basing on the modulus and the geometrical application bit. Okay, z1 comma z2 comma z3 are of a triangle ABC with the data they given modulus of z1 equal to modulus of z2 equal to modulus of z3. Then find the complex number. What is the complex number form of the its orthocenter? They are asking orthocenter of the triangle. Listen all of you. For this one, z1 z2 z3 are vertices of triangle ABC. These are the vertices already there. By data modulus of z1 equal to modulus of z2 equals to modulus of z3. What is this meaning? Modulus meaning means the distance from the origin to that particular point. So here by the observing the given data modulus of z1 equal to modulus of z2 equal to modulus of z3 means we can conclude that z1 comma z2 comma z3 are equidistant from origin O. That is, O is circumcenter of triangle ABC. So here the meaning is if you observe here, let this is A of z1 first point, B of z2, C of z3. By the data here this distance equal. Of course here S is equal to origin, since modulus of z1 modulus of z2 modulus of z3 equal. What is the geometrical meaning of modulus of z1? Modulus of z1 means root of x square plus y square from the origin to that particular point distance. So according to given data, indirectly what they given, O is the circumcenter. Then find centroid. Therefore centroid is equal to general formula only. What is the centroid formula? z1 plus z2 plus z3 whole by 3. Since centroid means in general x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3. Of course in the complex form you can mention as z1 plus z2 plus z3 by 3. So centroid G, circumcenter, if you know the circumcenter and centroid, can we find the orthocenter? What is the orthocenter formula we can apply? Okay, revise that concept one time. You can try yourself. Okay, how you can find the orthocenter if they given centroid and circumcenter and orthocenter. What is the relation? Centroid G divides circumcenter and orthocenter in the ratio 1 is to 2. So here the concept is, for example, this is the circumcenter, this is the orthocenter. Centroid G divides in the ratio 1 is to 2. Here H na orthocenter is H. This value, circumcenter is nothing but origin 0, 0, 1 is to 2 ratio, therefore this value also, simplify you can get the value. Okay, try yourself only, you will get simple logic. If you take, this is the Z, this is Z1, no, already Z1, Z2, Z3 is given, just you can take like this. G is equals to 1 into H plus 2 into S by 3 means here you will get 3G is equals to 3G is equals to 3G is equal, this is 0 na, since circumcenter is equal to 0 already given, we have to find this value. Therefore H is equals to 3G. H is equal to 3G means, therefore orthocenter H is equal to 3G means 3 into centroid G is given by this value. So Z1 plus Z2 plus Z3 by 3 both get cancelled. Therefore the orthocenter H is equals to Z1 plus Z2 plus Z3. Got it na? So this is the basing on the given data complex form, geometrical application complex form. Okay, got it na? I have that understand. Okay, next. Next one more example they given. One concept here. For example, collinear. For example, 3 points is given. 3 points means here let it be some A comma B comma C if they are collinear. That too here you may take A of Z1, B of Z2, C of Z3 are the points. These are collinear. The two here, if the relation is like this, let this is A of Z1, B of Z2, let this is C of Z3. If they are collinear, then geometrically in the complex form, how you can represent? Here, this distance plus this distance is nothing but from here to here this distance. So distance means what we are using? Modulus of the complex number. So here indirectly you will get modulus of Z2 minus Z1. What is this meaning? Modulus of Z2 minus Z1 means distance between these 2 points plus next BC. What is BC? Modulus of Z3 minus Z2 distance is equal to, what is the value will be? Modulus of Z3 minus Z1 is the value. So whenever if you observe this result, if Z1, Z2, Z3 satisfy this condition, automatically we can conclude that Z1 comma Z2 comma Z3 are collinear. Okay, this is also one geometrical application. The next one more example. Here the next one more example they given as Z1 comma Z2 comma Z3 are vertices of triangle ABC and modulus of Z1 minus 3 is equal to modulus of Z2 minus 3 is equal to modulus of Z3 minus 3 and Z1 plus Z2 plus Z3 is equal to 9. then find nature of the triangle ABC. This is the bit, okay. Here this is also geometrical application of complex numbers only. Here the example they given as z1 comma z2 comma z3. z1 comma z2 comma z3 are vertices of triangle ABC, and according to the data, modulus of z1 minus 3 is equals to modulus of z2 minus 3 is equals to modulus of z3 minus 3, and z1 plus z2 plus z3 equals to 9 is the value. Then what about the value? That means what is the nature of the triangle ABC they are asking. Okay.